Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called abcdefu by Sudoku. Hopefully we don't F you, but anyways, let's get to the rules. We have A, all rows equals 1 through 9. B, boxes equals 1 through 9. C, columns equals 1 through 9. D, diagonals equals 1 through 9. E, each crop key equals times 2. F, fill, V equals 5, and X equals 10. I hope you enjoy. So that is fun at the end. Interesting. For the actual rules, is normal Sudoku rules, which means because all rows, boxes, and columns must be filled with 1 through 9, and we have all diagonals also must have the digits 1 through 9 also. So, A through D, I would basically say, is fill in every cell with a digit from 1 through 9 such that there are no repeats in any row, column, box, or long diagonal. We also have black crop key dots, which means one digit is double the other. So for example, if this were, say, a 2, this would have to be 1 or 4 to maintain the 1 to 2 ratio that's between them. And for rule F, which is V equals 5 and X equals 10, these are normal VX pairs, where the two digits that share an edge with a V or an X must add up to 5 if there's a V in between them, and 10 if there's an X between them. So for example, if this were, say, a 3, this would have to be 2 because there's a V in between them and they must add up to 5. And if this were 3 and this would have to be 7 then, because they must add up to 10 because there's an X in between those two cells. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. Okay. We have two digits here which are in a 1 to 2 ratio with two other unique digits. So the only possible ones that could be there are 2 and 4. 2 can be in a 1 to 2 ratio with 1 and 4. 4 can be in a 1 to 2 ratio with 2 and 8. Okay. These digits must be 1 through 4 to add up to 5. Same with these. In this box, we are guaranteed if 2 is here, 1 and 4 are here. If 4 is here, 2 and 8 are here. So the rest of this box cannot contain 2 and 4. Well, that's also the case for this lower right-hand box here, right? If this is 2, this is 1 and 4. If this is 4, that's 2 and 8. So 2 and 4 cannot appear on this diagonal here. Where can 2 and 4 appear on this diagonal then? They have to be along this diagonal here. Well, that eliminates 2 and 4 to be next to any of the crop key dots. And the crop key dots cannot have 5, 7, or 9 next to it. So, because 5, 7, and 9, if you have them, you get 2.5, 3.5, 4.5. If you double them, you get 10, 14, or 18, none of which are digits. So therefore, 5, 7, and 9 cannot be next to these black crop key dots, so it has to be 1, 3, 6, and 8. Well, 1 and 8 are not going to be in a 1 to 2 ratio with any of those digits, so this has to be a 3, 6 pair, which eliminates 3, 6 in the rest of the box, so this can't be 3 or 6. This is 1 or 8 as a pair, which must be in a 1 to 2 ratio, specifically with 2 or 4. So this is 2 or 4, and this is 2 or 4. This can't be 2 or 4. because it's 1 or 3. 1 has to be in a 1 to 2 ratio with 2. 8 has to be in 1 to 2 ratio consecutive with 4. And therefore, these are different 2s and 4s. So they both see this cell, so this cannot be 2 or 4, which means where are 2 and 4 on this negative diagonal? They have to specifically be in these two cells. That leaves the remaining digits in the central box as 5, 7, 9. Okay. 2 and 4 is next to 6 and 8 here. To add up to 10. If this were 1, that would force this to be 2 and 8 to add up to 10, but that would also eliminate 8 from being there, and 8 would not be possible. So this cannot be 1 and 2. This must be 8 and 4, which makes this 1 and 2, so that makes that 3. 4 and 6 add up to 10 there. Okay. 4 eliminates 4 here, so that's 2, which makes this 1, 4 as a pair. This can't be 4 because of 4 in the row, so that's 1, this is 4. Let's see. Remaining digits. This again has to be 1, 2, 3, 4, 6, and 8. This can't be 2, 3, or 8. This can't be 1, 2, 4, or 6. So 3 could be here next to 6, or 8 could be here next to 4. This can't be 1. So if this is 3, this is 7. If this is 8, this is 2 to be in a 1 to 2 ratio. But if this is 4 and 8, that makes this 2, and 4 and 2 would eliminate all possibilities for that cell. So this cannot be 4. This must be 6 and 3 and 7 then to add up to 10. Okay, this can't be 3 or 7 to add up to 10. We have 1, 9, 2, 8, or 4, 6 here. No 2 here because of 2 in the column, so no 8 here. 6 cannot be here or here. Again, so this has to be 1, 2, 4, or 8 here. 1 cannot be on this negative diagonal here because of 1 in the box. 1 can't be here on this negative diagonal. Where is 1 on the negative diagonal? It must be here, which eliminates 1 in the rest of the box. So this must be 2, 4, and 8, with 4 being the middle digit in a 1 to 2 ratio with 2 and 8. 8 cannot be on this diagonal here. 8 cannot be on this diagonal here. Where is 8 on this negative diagonal? It must be here. Okay. Okay. What else do we have? 4 cannot be here, so this can't be 4 and 1 there. This adds up to 10. It can't have 2 or 4, so it's 1, 9, or 3, 7. Okay. This adds up to 10. It can't have 3, 6 as a pair. So it can't be 3, 7, or 4, 6. So it's 1, 9, or 2, 8 here. No 1 here means no 9 there. Okay. Remaining digits of column 1. We have 1, 2, 5, 8, 9. And this can't be 1 or 2. This can't be 2 because of 2 in the box or 1 in the row. This can't be 2 or 8 because of 2 or 8 pair in the box. And we don't know what this is. Remaining digits of row 7 are 5, 7, 8, 9. Obviously, 7 cannot be here because of 7 in the box. Okay. We are guaranteed this is 2 or 4. One of these has to be 2 or 4 to add up to 5. That eliminates 2 and 4 in the rest of the column. That doesn't really give us much, though. So it's 1, 3, 5, 6, 7, 8, 9. Obviously no 6 here because of 6 in the box. No 7 here because of 7 in the row. Okay. 3 in column 2, where can it be? Cannot be here because the 3 is in the boxes. Can't be here because of the 1 to 2 ratio. So 3 has to be one of these two. Interesting. Where is 4 in this lower left-hand box? Can't be here, can't be here, can't be here, so it must be next to the 10. So therefore, this is guaranteed to be a 4-6 pair, which eliminates 4 and 6 in the rest of the box. So that leaves 1, 2, 5, 8, 9 here. No 2 here. Where is 4 going to be on this positive diagonal here? Can't be here because of 4's in the boxes. So it has to be one of these 3 digits. Can't be here because of 4 in row in the column. So 4 has to be here, which means this cannot be 4. This is a 2-3 pair, which eliminates 2 and 3 in the rest of the column. So no more 3 here, no 3 here, so that's 6 and 3. No 2 here, so that's 4, which makes that 2. This can't be 2 and 8 to add up to 10, so this is 1 and 9. No more 3 here, no 6 here. We have 1, 5, 7, 8, 9 remaining. Where is 2 in row 1? Can't be here because of the 2-8 pair in the box. Can't be here because of the 2-3 pair in the box. Can't be here because of 2 in the column. So it has to be here, which means this is 2 and 8 adding up to 10. Where are 2 and 8 going to be on this positive diagonal? They can't be here because of 2, 8 already in the box. Can't be here because of the 2-8 pair in the box. So they have to be along this diagonal. So 8 cannot be here. 8 is on the diagonal and 2 is on the diagonal. This can't be 8 because of the 2-8 pair in the box. Where is 3 then on this positive diagonal? Can't be here, can't be here, so it must be in this box here, which means this cannot be a 3-7 pair here, adding up to 9 or 10. It has to be 1 and 9, which leaves the remaining digits in this box as 3, 5, 6, 7, and 3 must be on the diagonal again, remember. Okay, 9 can't be on this diagonal. We have guaranteed 3. 6 can't be on this diagonal. So we have 3 with 5 or 7 here. We have a 3, 5, 7, 9 quadruplet on this positive diagonal. That eliminates 3, 5, 7, 9 on the rest of the diagonal. This can't be 5 or 9. It's 8, which leaves this as a 1, 2 pair. And this can't be 1. This is 5, 9 as a pair. 8 eliminates 8 here and 8 here. So 9 has to be on this diagonal here. This cannot be 9 then. 1 and 9 eliminate 1 and 9 in the rest of the row. Remaining digits in row 4 are 4, 5, 7, 8. No 4 here because of 4 in the column. No 8 here because of 8 in the column. So 4 has to be one of these two. Okay. One of these is 9. Where is 6 in this lower right-hand box? Cannot be here because of the 4, 6 pair in the row, so it has to be one of those two. Where is 6 in this upper right-hand box? It's one of these two digits because it can't be on the positive diagonal, so where is 6 in this right central box? Can't be in any of column 7 or 8 because we are guaranteed a 6 in column 7 or 8 in this box, and we're guaranteed a 6 in column 7 or 8 in this box. So it has to be in column 9, cannot be here because of 6 in the row, so this is 6. Remaining digit, where is 4 in row 5? Can't be here because we have guaranteed a 4 in one of these two cells in this box. And can't be here because of 4 in the column, so 4 has to be here. So remaining digits, we have now 3. Where's 3 in row 5? It has to be here. So that's 3 there. Which leaves the remaining digits in row 5 as 5, 7, 8, 9. Where's the 1? 1 has to be here in that box. 1 eliminates 1 here, so that's 2 and 1, which eliminates 2 here, so that's 8 and 2, which eliminates 2 here, so that's 3 and 2 there. So 8 eliminates 8 in the rest of the column. 1 eliminates 1 in the rest of the column. Remaining digits, so in row 6, where can 9 be? 9 cannot be here because 9 in the box, so 9 has to be here. Which means this can't be 9 here. This is 5, 7 as a pair, which eliminates 5 and 7 in the rest of the row. So this can't be 5 or 7, it's 9. This can't be 5 or 9, it's 8, which means this can't be 8, it's 5, which eliminates 5 from the rest of the row here. This can't be 5 or 7 because of the 4, 7 pair in the row. So this can't be 5 or 7, it's 8, which means this can't be 8 here. 5 eliminates 5 here, so it's 9. Where is 8 on this diagonal now? It has to be here. That 8 eliminates 8 here, so that's 2 and 8. Remaining digits of that leaves this as a 6, so this cannot be 6 here. Where's 6 in this upper right-hand box? It's there. Remaining digits of row 6, we have 2, 5, and 7. And this can't be 2 because of 2 in the column. That leaves a 5, 7 pair there. 1 eliminates 1 here. 9 eliminates 9 there. 3 eliminates 3 here. So where 3 has to be remaining here in column 2. Where is 3 then on this diagonal? It has to be on this negative diagonal. It has to be here. So that's 3 in the corner, which eliminates 3 in the rest of the column. This 2 eliminates 2 in the rest of the column. We have a 5, 7 pair here, which eliminates 5, 7 in the rest of the row. So that's 2. This 5, 7 pair eliminates 5 and 7 in the rest of the box. So that's 3. We need this 9 eliminates 9 in the rest of the diagonal. So this is 5, 7 as a pair, which eliminates 5, 7 in the rest of the diagonal. So this is 1, 6 as a pair. And this can't be 1 because of 1 in the column. So that's 6, that's 1. That leaves this as a 5, 7 pair. 1 eliminates 1 here, so that's 9 and 1. Remaining digits of row 3 are 5 and 7. Remaining digits of row 2 are 8 and 9, and this 9 eliminates 9 here, so that's 8 and 9 there. This 5, 7 pair eliminates 5, 7 in the rest of the box. This can't be 5 or 7. It's 1. So no one here. Remaining digits of row 1 are 4 and 6, and this can't be 6 because of 6 in the column. So that's 4, that's 6. Okay, remaining digit of this lower right-hand box is a 9, which eliminates 9 here. We have 8 ones. We know where the last one has to be. It has to be there. Also, 8 eliminates 8 as a possibility there. We should have 8 twos. We do. We know where the last 2 has to be. It has to be there. Threes. We have 8 threes. We know where the last 3 has to be. It has to be there. We should have 6 eliminates 6 here, so that's 4 and 6. 9 eliminates 9 here, so it's 5 and 9. 4 eliminates 4 here, so it's 7 and 4. 5 eliminates 5 here, so that's 7 and 5, which eliminates 5 here, so it's 7 and 5, which eliminates 5 here, so it's 7 and 5. 7 on the diagonals eliminates 7 here, so it's 5 and 7. 5 eliminates 5 here, so it's 7 and 5. 7 eliminates 7 here, so it's 5 and 7. This can't be 5 or 7. It's 9, which makes that 5. And that can't be 5 or 7. It's 8, which leaves that a 7. And that's the solution. Yeah, fairly straightforward. Just normal Sudoku rules with the diagonals. The diagonals were pretty key, I guess. And then you had the crop key pairs to disambiguate things. Yeah, I mean, I'm not sure how else to, what else to talk about. It's fairly straightforward if you know the rules. But that's always the case, isn't it? I don't know. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.